Now, the random library within Python is a particularly useful library for our kind of work because it allows us to generate random numbers. It's got lots of really useful methods that allow us to do that. And that is particularly useful for us because most of the models that you're going to be building, most of the models we're going to show you how to build on this course, with the exception of one example, which isn't based in Python anyway, um, are going to be what is known as stochastic models. So there are two types of models: stochastic and deterministic. A deterministic model means you plug in the numbers, and every time you run the model, the same results come out. There's no randomness. It'll always give you the same results given the same inputs. But most of the models you will build are stochastic models. And we talked about a couple of weeks ago why we need to build stochastic models, because the kind of systems that we are building, that we are modeling, have randomness in them. We don't model an ED where everyone spends exactly 3 minutes with the nurse and spends exactly 17 minutes with the doctor. It doesn't work like that. There's real world variability, and that real world variability is important in things like a queuing model, because whether the patient spends 17 minutes or 15 minutes can have a knock-on impact in terms of a queue building or not at all. And all those little variabilities can be incredibly important. So you will generally be building stochastic models. And you'll remember we talked about, in order to do that, we use these things called probability distributions, which is basically our way of representing variability within our data. And the way we do that is we say, well, on the y-axis we have the probability of any value on the x-axis occurring, and we use that essentially to represent various activity times and inter-arrival times in our model. So we can say, well, there's a 50% chance for any patient that comes in, a 50% chance they spend 3 minutes with the doctor. There's a 40% chance they spend 4 minutes with the doctor, etc. And we tend to do that using named distributions. You remember we talked about we tend to use mostly exponential and log normal distributions, and feed in our particular parameter values that then shape that particular distribution. So that's why the random library is going to be useful, but obviously we haven't taught you how to do SymPy or anything like that yet. That's to come in a few weeks. But for now, it is going to be useful for this afternoon as well. So we're going to use the random library. So to import the random library into our code, we can simply say import random, put that at the top of our code. We don't need to pip install random. Random comes with the Anaconda distribution of Python. I can't remember if it comes with core Python or not. I think it does, but if it doesn't, I mean, you're using Anaconda, so it definitely comes with Anaconda, and that basically says, okay, I'm going to in my code, I'm going to need the random library. It's good practice if you find you don't. Sometimes you import something and think, oh, I didn't need that in the end. Get rid of it, delete it. You don't want to be importing things that you don't need. So only import stuff you do. By the way, for most of the stuff you'll be doing moving forward, you will be importing pandas, NumPy, and matplotlib, plus some other stuff. Those are the three big packages for data science that you will need for a lot of what you do. So here's some useful methods that you can run with the random library. So random.random, there's our dot notation again. Remember that saying, from the random class, give me the random method. So that random method just gives us a random number between 0 and 1. And it samples that from a uniform distribution. For those who don't know, a uniform distribution just basically means every possible value is equally likely. That's all it means. So there's an equal chance of any number between 0 and 1 being picked. That's quite common when you use random.random, because very often you need to randomly generate a number between 0 and 1 to determine some sort of probability or something like that. So random.random is quite useful. You can also, though, generate a random integer, whole number, and you can use random.randint for that, and you specify the number you want to go from and to. And remember I said you're going to see some examples where it doesn't play by the rules. So up to now I've said it's from this up to but not including the top. That doesn't apply for random.randint. That includes the top value. So that does mean, and it give me any number between 1 and 10 inclusive. So 10 can be picked. Just to further confuse you there. It is the exception though. Generally, stuff like this, it normally doesn't include the top. You can also use random.choice if you want to randomly select an element from a list. So imagine I've got a list here. My list has got Dan, Sammy, and Amy as the entries. If I call random.choice and I pass in the name of the list, it will randomly pick one of the items in that list. And again, that can be really useful as well.